We're going to start with taking the derivative of the inverse secant of 6x. So if y is the inverse secant of 6x, secant of y equals 6x. Let's take the derivative with respect to x of both sides. The derivative with respect to x of secant y is the derivative with respect to x of 6x. Hopefully you know the derivative of secant is secant tangent. So the derivative of sec y will be sec y tan y dy dx equals the derivative with respect to x of 6x, which is just 6. And then solving for dy dx, what do we get? We get dy dx is 6 over sec y tan y. And we're not finished. We need to determine what secant y and tangent y are in terms of x. Now we know secant y is 6x, so we can make that substitution right away. Again, notice secant y is 6x. So we have secant y here. So we can go to our next line and say dy dx is 6 over 6x tangent y. All right. Now what is tangent y? I certainly could use the identity. I could recognize that 1 plus tan squared theta is sec squared theta. So I can certainly use y instead to say 1 plus tan squared y is sec squared y. But I know secant y is 6x. So 1 plus tan squared y is 6x squared. So 1 plus tan squared y is 36x squared. So tan squared y, 36x squared minus 1. So tangent y, ignoring the minus, is the square root of 36x squared minus 1. That's one way to get that. The other way to get that is by playing with triangles. So secant y is 6x, which would mean cosine of y is 1 over 6x. So drawing our triangle, cosine is adjacent over hypotenuse. We'll draw the triangle. Cosine y adjacent 1 over the hypotenuse is 6x. Let's call this third side, I don't know, call it a. So a squared plus b squared is c squared. So a squared b squared is 1 plus 1 squared is 6x squared. So a squared plus 1 is 36x squared. So a squared, 36x squared minus 1. So a is the square root of 36x squared minus 1. So what does our triangle look like? 6x here, 1 here, there's y. And we just said a was root 36x squared minus 1. So looking at that, then, what can we say? Tangent is opposite over adjacent. So if that's the case, what do we have? Tangent is opposite over adjacent. Tangent y is root 36x squared minus 1 over 1. And you can again see what we had before with the identity. 36x squared minus 1. So what is my dy dx then? 6 over 6x root 36x squared minus 1. And the 6's divide out. And where do we get to? We get to dy dx, which is what we're looking for. Is 1 over x root 36 x squared minus 1. All right. So let's go ahead and reverse this process now, and we're going to use the triangles to do that, to find an integral of a problem that looks kind of like this. So let's take a look. Let us do the integral. One is fine over, let's make it 3x times the square root of 25x squared minus 4 dx. And we have some work to do. Now, the previous triangle kind of gives me an idea where this is headed. So where is this headed? What am I going to do? I do want to draw a triangle. And this triangle that I'm going to work off of is based off of a squared plus b squared equals c squared. Now, this is not c squared because it's not a sum. So it's either a squared or b squared. Let's call it a. We'll make 25 root 25x squared minus 4. Then we can square that plus something I'm going to want for my b squared to equal c squared. So hopefully you can see where this is headed. 25x squared minus 4. To get rid of the number here, I'm going to have to add 4. So if that's the case, b squared is 4. And then what's left here is c squared. So I've got 25x squared is c squared. So looking at this, b squared is 4, so that would make what? B equal to 2. C squared is 25x squared, which makes c equal to 5x. Now, where are we going to put these things? C is 5x, so fine, we'll call this angle theta for now. C is 5x, that's the hypotenuse. Great. I need b to be 2, and I need a to be root 25x squared minus 4. So how am I going to do that? How am I going to do that? Well, let's keep this as simple as we can keep it. So we recognize that secant is what we did before, which is going to be like cosine. We want to keep the cosine part simple. So I'm going to call this part b. And we'll call this other part root 25x squared minus 4. So we have our Pythagorean triangle, and we can do a little bit of analysis here to try to make some sense where this is going. So our simplest ratio, not this piece and this piece, adjacent and hypotenuse, that's cosine. Cosine of theta is 2 over 5x, which means secant of theta is 5x over 2. We kind of had an idea this was going to be secant. They wanted to keep secant nice, which is why I put the 2 here rather than there. Although you can do it mathematically the other way. You're just going to have some negative numbers. So, okay, we have what secant theta is, and I need to get dx, so I can certainly get that. How do we get that? 2/5 of secant theta equals x. Let's take the derivative with respect to x of both sides. The derivative with respect to x of 2/5 secant theta is the derivative with respect to x of x. What do I get? Here we get 2/5 sec theta tan theta d theta dx equals 1. And then to finish this off, I'm going to solve for dx. That's what I need here. So we get 2/5 sec theta tan theta d theta equals dx. So I'm going to need that. I'm going to need that dx here. We see dx here. That'll be this dx. I'm going to need x, which I have here. And the last part that I need is I need to figure out what the root 25x squared minus 4 is going to be. Okay. Let's go back and look at our triangle. There is our triangle. And I want to figure out the simplest ratio that has root 25x squared minus 4. That would be this piece and this piece, not these two, they both have x's. So tangent of theta, simplest piece. Tangent of theta, opposite over adjacent, root 25x squared minus 4 over 2. So knowing that, then we want to solve for that root 25x squared minus 4. So 2 tangent theta is going to equal root 25x squared minus 4. And this we're going to need to substitute as well. We have all of these pieces that we need to substitute. Let's look at the 3 pieces. Again, x is 2/5 secant theta. Dx is 2/5 secant theta tan theta d theta. And root 25x squared minus 4 is 2 tangent theta. We're going to make all those substitutions in the original question to go ahead and evaluate that integral. So let's rewrite that on a new sheet of paper. Our original question again was integral of 1 over 3x root 25x squared minus 4 dx. Let's make our substitutions. First off, 1 over 3. What was x on our previous page? What did we see? We see x was 2/5 of secant theta. So we're going to replace the x with 2/5 secant theta. Then we need what? Then we need root 25x squared minus 4. What did we say that was? We said that was 2 tangent theta. That piece. And then what is dx? What did we say dx was? Dx was 2/5 sec theta tan theta d theta. We get 2/5 sec theta tan theta d theta. And look how nice things divide out here. 2/5 over 2/5 gone. Sec theta over sec theta gone. Tan theta over tan theta gone. What's left downstairs? 3 times 2, 6. What's left upstairs? 1. So we get 1/6 integral of d theta, which is 1/6 of theta plus c. Now, what is theta? If we go back to our first page, we said sec theta was 5x over 2. Yes, cos theta is 2 over 5x. You could say inverse cosine, but we typically stay away from the cofunctions. Sec of theta was 5x over 2 is what we had said. Let's write that down. If sec of theta is 5x over 2, theta then is the inverse secant. Of 5x over 2. So where does that put us? That finishes this up with 1/6 inverse secant 5x over 2 plus c.